Example 3.20. A particle of charge q moves with velocity v along positive y direction in a magnetic field. Compute the Lorentz force experienced by the particle A when magnetic field is along positive direction. B when magnetic field points in positive z direction. C when magnetic field in zy plane and making an angle theta with the velocity of the particle. Mark the direction of the magnetic force in each case. Okay. Now what is given here is a particle is moving with velocity v along the y direction in the magnetic field. Now we have to find it out the Lorentz force in three cases. One is when the field is along positive y direction. Another one is when the field is along positive z direction. And another one is the field is in zy plane. We'll go one by one. Okay. Now first initially what is given as is velocity of the particle. So the velocity of the particle is that is v vector. V vector is in positive y direction. Positive y direction means what? J vector. Positive y direction means what? J vector. So into v into what? J vector. Okay. Now we'll go for the first case. So when magnetic field is along positive y direction. So what you can write? B vector is equal to B into J vector. Okay. So you can write here both in the diagram. This is your y, z and x. Velocity of the particle is also in the y direction. So this is the velocity of the particle. And the magnetic field is also in the same direction. This is your magnetic field. Okay. So we can write the Lorentz force now. So this is what we have to calculate. So the Lorentz force is equal to F vector is equal to Q into V cross B. Here V is what? V into J vector. Cross B into what? J vector. Now since both are in the same direction, both are in the J vector direction. Okay, or in the positive y direction. What is J cross J? J cross J will be what? 0. J cross J will be what? 0. So what you can say, there is no force acting on the particle when it moves along the direction of magnetic field. That is, the particle and the field are in the same direction. When they are in the same direction, there is no force is acting on the particle. Okay, so the Lorentz force acting on the particle is 0. Now coming to the second case, B. Now what is B? Magnetic field points in positive z direction. Okay. So what is the magnetic field here? B vector is equal to B into K vector. Now we'll draw here. The velocity of the particle is here in positive y direction. But the magnetic field here it is positive z direction. So this is the direction. Okay. Now we can go for writing the Lorentz force. So Lorentz force F is equal to Q into V cross J vector cross B cross K vector. Okay. V cross J vector cross B cross K vector. So what will you get here? You will be getting here it is J cross K. What is J cross K? J cross K is I vector. So you can write QVB I vector. So the magnitude of the Lorentz force is what? QVB. And the direction of the Lorentz force is along what? Positive I direction. So which is the direction here? It is the positive x axis. So this is your direction of the Lorentz force. This is your direction of what? Lorentz force. Now coming to the next case. Okay. So what is the next case? When magnetic field is in zy plane. and making an angle theta with velocity. Okay, so we can draw it out here. The velocity of the particle is here in the positive y direction. Now the magnetic field is making an angle theta with the velocity like this, and it is in the zy plane. Okay, now we can write the value of the magnetic field. The magnetic field can be resolved into two components. One is along the y axis and another one is along the z axis. That is the horizontal component along the y axis and the vertical component along the z axis. So we can write the magnetic field B as B cos theta into j vector plus B sin theta into k vector. Now we can write the Lorentz force. Lorentz force is equal to Q into Bj vector cross B cos theta into j vector plus B sin theta into k vector. And this can be written as Q into Vj vector cross B cos theta into j vector. It will become what? 0. Both are in the same direction. So what will you get? Vj vector cross B sin theta into k vector. So here we can write Q. J cross k is what? K. So QVB sin theta into J cross k is what? I. J cross k is I vector. So what is the direction here? Here also the direction is along the positive x-axis. It is along what? Positive x-axis. What is the magnitude? QVB sin theta. So when it is inclined at an angle theta with that of what velocity of the particle, you are getting the force in what? Positive x direction. Positive x direction.